Hi folks, welcome to today's class. So today we're going to be going over some clipping work on some satellite imagery. So the first thing I'm going to do is I'm going to get open my Anaconda prompt. I'm going to go to where my files are, and I'm going to activate the SEER Conda virtual environment that we've been working in, okay? And I'm just going to open up my Jupyter notebook in that particular location. Hopefully you've already had a chance to go online and essentially get the actual notebook for this week's work downloaded and open on your machine, okay? So here you'll see it's 8.0 clipping, and you will also need to make sure that you've got access to this file, which should also be on the GitHub for you to download, okay? So essentially, what are we going to do in this tutorial? We're going to look at how you take a much larger satellite image, which is something that we've been dealing with on a weekly basis, and then essentially define an area of interest and then cut out that area of interest from the much larger image. And I think that this is very valuable because a lot of those images that you've been kind of critically reflecting on when you've been doing your home assignments and essentially downloading imagery from either Sentinel or Planet, you will have recognized that some of those images are essentially huge, vast areas that are being photographed, okay, and sent as digital images for us to access. And often they're just too big for us to kind of be working with on an easy, in a kind of efficient way. You know, even I have had problems kind of downloading or uploading some of those images onto the GitHub because the files were too large. So this is a really nice thing to be able to do. It enables you to kind of clip to your specific area that you might be focusing on, whether that's looking at glacial activity or looking at water changes in particular areas via imagery approaches. But essentially enables you to really kind of get a smaller image of the key part that you're interested in from a larger case. Okay, so you're going to need to actually access this particular image. So what I've been doing here is I've just got a little bit of script for you to first open up that particular image within this existing notebook. Okay, so nothing here should be new to you. We've covered this before in how you visualize an image from within Jupyter Notebook. So we're importing rasterio in order for us to actually load that raster image. We're actually loading in that matplotlib function as PLT here, and that enables us to actually look at our underlying image that's available, and then we just use this numpy function, numpy, as MP to actually scale the underlying values. Okay, so we're basically specifying this particular image here, which is one which I downloaded from Planet, which is of the Chesapeake Bay area. It's basically of Annapolis Harbor, and essentially this was taken in August this year on the 20th. And essentially we're able to open that up. So you give it the image file name. We can open that up by basically getting a rasterio object, here my raster image, by using this rasterio.open function. Okay, so you should be kind of remembering that we've covered this before in the existing classes. Now we do need to slightly scale some of our bands, so we have this scale function here, which I've just slightly adjusted for this particular image. And then essentially what we're going to do is we're going to specify our multi-band layers. Okay, so the first one is going to be blue, the second is going to be green, the third is going to be red. And then essentially I just use that numpy stack to put them into the correct order again, and then essentially show it using the plt.imageShow function. So let's have a look at that. So that should all be fairly well trodden ground to you. This is the underlying image, and there's been some processing of that image as we've kind of manipulated it here, for example. So you might find that the actual coloration of this image looks a lot more bleached out than some of the others. Sometimes that's because you have some rounding effects when you're scaling, and that ends up changing the underlying values. But we are able to also take a look at the original image, which probably looks better true color if you view it here within QGIS, so you can use whichever your preferred GIS software is. But essentially, I'm looking just here at this picture of the Chesapeake Bay. So if I just zoom out, all of a sudden you can see the DMV area here, Baltimore up here to the northeast as well. And then essentially we've got Annapolis over here, which is where the Naval Academy is. And we're able to take a look at that view of the actual harbour area. Okay, so for anyone who's actually been out on this, it might look like a small area, but it's actually a huge area for an inland estuary. Okay, so let's get started now. What we want to do is we actually want to produce a little clipping example of that image, right? So, for example, I could create a little box. We could do that manually. We could create a shape file here where we actually draw out a little box here that we essentially want to clip. So I'm not going to do that in this particular instance. We're actually today just going to specify a geojson polygon shape for any area within here, okay? It's really just a demonstrable example of how you carry out this technique, okay? So we could, in future classes, take shape files that you particularly want to clip an image to, and then we could reapply this process using those imported shape files. But today we're just going to basically hack together a geojson shape within our notebook and use it to actually clip this underlying image, okay? So in future cases we will load in an area of interest, but today what we're going to do is going to start by getting the bounds of this particular image. Okay, so here this is in meters. It's this projected coordinate reference system EPSG 32618, and essentially you can see that we've got the bounds, the very outsides of each of these image locations. So it's the minimum, the maximum of the x and the y axes. Okay, so if you're still stuck for what that is, you shouldn't. But if you're still stuck for what that is, just remember this is essentially just like a graph. And in that graph, we have our different axes, the y-axis going to the sky, the x-axis horizontal on the bottom, and essentially what we're getting are those minimum, maximum points along those different axes. So to specify the GeoJSON, I know you've had experience now working with GeoJSONs because we've used them a couple of times. I think the key thing is that you just need to be careful how you're specifying either a point or a polygon, because most of the time when you're getting errors, it's because you specify the GeoJSON incorrectly, right? So you've either used too many brackets or you've not used enough brackets, and maybe 30 to 50% of the problems that we see when we do practical examples is people misspecifying the GeoJSON structure, and that's not going to be any good for actually doing the processing that you want to carry out, because the code in each of those packages for carrying out an image manipulation is going to be looking for a specific structure, the same way as if you're passing an incorrect GeoJSON shape to an API for a server which has imagery. They're all going to be looking for a specific GeoJSON structure, and you're going to be giving an incorrect structure, and therefore the query that you produce or the processing that you're carrying out will fail. Okay, so make sure that you get that correct. Here we've got a point, which is fairly straightforward. It's slightly more complicated if you have a polygon, but I've provided plenty of information for you to look at those polygon structures in the previous classes or here. You can even just type it into your search bar. Okay, so what we're going to do first is we are going to create a new set of minimum and maximum x and y coordinates. Okay, so if you think at the moment what we have here is this image, we're going to take the minimum, the maximum points, and then we're going to basically get points that allow us to be within this overall box. Okay, so we're going to create a small little box which sits within this overall square image and then allows us to clip just to that single box that's within this image. Okay, so we're going to need to get smaller coordinate values which allow us to be within these particular points. So what we're doing first is we're going to essentially take those minimum and maximum values from the bounds, and we're going to get the range. Okay, so essentially what we've got here for the range is we've subtracted the minimum x from the maximum x value. So the minimum x is here, the maximum x is over here on the right hand side, and we've subtracted them so that we can get this range value inside here. Okay, you should just be able to see on my screen the hand bar moving along this x-axis, and when we get those min and max points, it allows us to respecify along this interior part of this axis. Okay, we can do the same for the y range as well, and what I've done is I've just printed out that x range and the y range value here, which should be in meters, and I've rounded them just so that we don't have, 1,300.04000000. I'm just rounding them basically to be, I think, whole numbers here. Okay, so this round basically allows you to specify how many numbers you would like to round your quantitative information to. If you don't specify anything, I think it just rounds it to the nearest whole number. So here we go. We've got 9,213 meters and 7,554 meters for the X range and the Y range. So not quite as square that we have here. It's rectangular, but it broadly looks quite symmetrical when you look at it. It doesn't look too skewed in any particular direction. Okay. And those initial values that we basically have, which we specified already for the bounds, are here. And essentially what we're going to do now is we're going to re-specify those minimum and maximum values. So what we have listed down here that I'm highlighting is just the output of this printed statement, which just basically takes the minimum x, minimum y, the maximum x, and the maximum y. And then essentially we're going to re-specify them here. Okay, so the minimum x is actually going to have 1/3 of that x range added to it. So it's going to go from 370,695 is going to go to 373,766. Okay, so we're basically going to move that minimum x value slightly along that x-axis so that we get a new x coordinate for the minimum value for our new coordinate box, our new GeoJSON shape. And then for the y minimum, we're going to do the same there. Remember, we would be adding this value to the minimum value, whereas in the case of the maximum values for the x and the y axes, we're going to need to subtract part of that range value, okay, from that the maximum values here. And as you can see, I've just kind of printed out these values down here so that you can see the values that we had at the beginning, the initial values, and then the final values that we end up having. And these are obviously coordinates that we can use to draw our GeoJSON box, which allows us to clip that underlying image. Great. So now we can get on with actually specifying that area of interest. So remember, we use this AOI, area of interest acronym, as it was quite commonly used within the Planet API documentation. And essentially what we're doing is we're going to specify a GeoJSON here. So the GeoJSON is actually the dictionary part, the curly brackets bit, and it's actually within this list that we're allocating it to. But essentially we're going to say that this is a polygon, so the type equals polygon. So this is the geometry structure, and then we're going to basically say that the coordinates are, and we're going to specify our tuple coordinates, and the tuple coordinates are going to end up being the points, the 4 points that you have, which enables you to draw an actual box. Okay, so you can imagine, you can imagine that we have our square here. We're going to want to draw another one inside, which broadly replicates this existing structure. Okay. So we did see on the exercise that many people were basically changing point to a polygon here and then writing their coordinates in. Remember that you have here, for these coordinates, what you have is a list of lists, basically. And you don't need that for a point. Okay, and for a point you just have a list of the coordinates. So you need to make sure that you get the right structure in order to specify this area of interest. And hopefully if you've done that, then you're able to get something printing out broadly similar to this. So you don't have to, in this particular example, specify these by hand, although you could do. You could just look at the x and the y coordinates within a GIS that allows you to look at the underlying units, and then you could specify your box that way. But here we're kind of doing it in a more sophisticated way today, doing a little bit of coding in order to get those minimum maximum points. So bear with me while we piece all of this together. So now essentially we've got our area of interest that we're going to clip that larger image to, okay? And essentially what we need to do at this point is we need to load in this new package from rasterio, this new function, sorry, called mask. Now what does mask do? Well, you can think of it literally, you know, a mask goes over a face. The idea is that a mask basically enables you to actually hide any areas that lay outside of a specific point that you want to clip, okay? So you can either include them or exclude them depending on how you use the mask. In this particular case, what we're essentially going to be doing is going to be masking out those areas that lay outside of our area of interest geojson polygon that we've just specified, okay? And then essentially that means that we can get a clipped image of just the underlying data. So you can load in that particular function mask just here, and then we can move on to actually clipping the underlying image. Okay, now this looks slightly complicated, so I'm just going to break it down, but basically you'll notice whenever we're working with rasterio, because we have been over the last 4 lectures now, so this should be quite commonplace to you, that we always use this with statement in order for us to then do something with rasterio. So in this case, what we're doing is we're saying with, and we're using the function rasterio.open, and we're giving it the image file name that we've got. And then basically what we're going to do is we're going to use this mask function. So we're saying we want to pass to the mask this underlying image file here, which is loaded in as img for image. We're going to give it the area of interest, which is my geojson that we just specified, and we're going to state crop equals true. You can go and look at the documentation for the mask function, which states exactly the type of arguments that it wants to be provided with. But in this case, it's the lowest unit of any sort of example that I can give you. So it's just an existing image followed by an area of interest, and then you're just telling it crop equals true, okay? And it's going to take that image, it's going to crop it to the area of interest, and it's going to return the clip data, okay? So this is basically what we're getting back on this left-hand side here. So this is how we open the image here. This is how we mask that underlying image that we've just opened using the area of interest. And then basically this is our output that we get, which is the clipped data here. And remember, this is a, what is it? It's a NumPy array structure, and it's a multi-dimensional list of lists in this particular case. Okay, so you can see that it's multi-band information because you have a dictionary here for one layer, followed by another list here for this layer. Sorry, so a list here for the first layer, a list here for this second layer, a list here for the third layer and the fourth layer. Okay, so we've got 4 layers within this particular example. So we've got the near infrared band as well. Okay, so that might not be that intelligible to you at the moment, but bear with me, because what we're going to do next is we're going to basically first get the metadata ready for us to then basically write and export this new clip data so that we can visualize it within a geographic information system. Okay, so essentially what we need to do first is we want to actually copy the metadata that's available to us. So let's have a look at this box here. So this is the metadata for the original image. You can see that the width and the height here is specified. We've got 4 bands, we've got a CRS, a coordinate reference system, and we've got a transform, a feed transform function. Essentially, not much of this is going to change, but what we do need to do is we need to write over it and re-specify the height and the width of the new clipped image. Okay, and you'll see that when we did that, what we did here was we printed out the metadata and we've reallocated the new width and height. And this is important information because basically, along with the affine transformation function, this basically is going to tell a piece of GIS software, whatever you're opening, how it should display that image. Okay, so what type of geographic space it's in and what the width and height is that's going to be used. Okay, so this is the final function now. This is the end of that processing piece. Essentially what we do is we just basically say that we want to write that information out. Okay, so here you'll notice again we use the with the with capability, and then we also are using this rasterio.open function to basically open a new file here called clip.tiff, but the difference is we're actually going to not read from this file, we're actually going to write to this file. So basically we're saying rasterio open clip.tiff, we want to write to this file, we want to give it the metadata that we've just edited, and we want this to be our writer object, okay, and that sets up the structure for everything that then we basically write into. Okay, so here what we're doing is we're giving it the clip data and we're giving it to .write, and it's basically going to pump all of that data into the file structure that we've just specified. Okay, and when we do that, we should get writing complete. So now we should be able to go and view our clipped.tiff somewhere within our GIS. Okay, so I've got it here in my particular folder structure where I'm working from. I can see I've got the clipped image there, and what I'm going to do is I'm just going to import that clipped image, drag and drop it in, and you can see that we've got something that's broadly about 1/3 of the size, well, it was 1/3 of the width and 1/3 of the height of the previous image. Okay, and now you might be asking, okay, so why do we have such a large difference in the contrast? And that's just because some of the values have basically been, the underlying values have been changed as we've carried out that manipulation, potentially because of rounding issues when we've been kind of moving between different data layers. Okay, but essentially what that's provided you with is a clipped version of this underlying image just at this particular smaller scale size. Okay, so you've got the code for this. You've got the code for it. You can basically collate together that code into a new notebook so that you can begin to get on with the exercise that we're going to be working on this week. So essentially what I want you to do is I want you to get an image downloaded from Planet for the Thomas Point Shoal Lighthouse. So you can either get coordinates for that particular location. It's also in the Chesapeake Bay. And essentially, I want you to download an image there, and then you can do things like count the number of ships or boats that might be present in that particular image. Okay, so in this exercise, what you're going to need to do is to first download that image. So you need to get the Planet API code together. You might want to do this in a separate script to download that Thomas Point Shoal Lighthouse image. And then essentially you can open up that image like we did today using Rasterio. You can inspect that that image has been loaded correctly. And then essentially what you can do is you can clip that image using a bounding box, okay, an area of interest, geojson, polygon, either that you specify yourself or you specify in some other way that you're interested in just breaking down the problem. And what I want to be able to see is I want to be able to see you actually have that image with another image that you've then been able to clip and get working for a smaller area within it, okay? Just to demonstrate that you're able to basically get the basics of clipping an image using this code-based approach, okay? So you can then write out that image to a particular location. You can critically review the image that's there, okay? So you can look at the information that's present on that image, but you can also reflect on the method that you've carried out in order to get to that particular place. Great, well, thanks for tuning into this today. I'll look forward to seeing you all in person at the next class. And essentially we'll be able to look both at this exercise, the results that you've got, and then also you can follow up with myself or with Mark and Alice to ask any further questions that you might have on the code or the overall work that's being set in general. Okay, thank you for tuning in, and I'll see you all soon. Take care. Bye-bye.